In previous class, I told you about the valency of element and radical, and this is just for the preparation of writing chemical reaction. Now, if we remember the valency of these elements, what I wrote in previous class, and valency of these radicals, valency of these elements and valency of these radicals, then we'll be able to write molecular formula of different compounds, and then only we'll be able to write chemical reaction. In last class I told you about the variable valency of metals. Today we'll start with variable valency of non-metal and then molecular formula. Okay, now let's talk about this variable valency of some elements. Sulfur has three different valency. 2, 4 and 6. This is non-metal, it has three different valency. In sulfur dioxide, valency of sulfur is 4, but in hydrogen sulfide, its valency is 2. In sulfur dioxide, valency of sulfur is 4. In the same way, in sulfur trioxide, valency of sulfur is 6. Look at this. Sometimes valency of sulfur is 2, sometimes its valency is 4, sometimes its valency is 6. Sulfur has different valency in different reactions. This is variable valency of one of the element, that is non-metal sulfur. And now another, nitrogen, its valency is sometimes 3, sometimes 5. In normal cases, sulfur has valency 2. In the same way, in normal cases, valency of nitrogen is 3. Just like in ammonia, NH3, valency of nitrogen is 3. But in case of radical ammonium, NH4, its valency is 5. Here its valency is 5, here its valency is 3. Normally we will take valency of nitrogen as 3 and sulfur, valency of sulfur as 2. This is a little about the variable valency of non-metal. Now we are starting this molecular formula. How to write molecular formula? Look at this. I want to take some of the compounds and I'm writing molecular formula of these compounds. Let's say magnesium chloride, MAGNESIUM, magnesium, CHLORIDE, chloride. I want to take some other also, aluminium, 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 NITRIDE, nitride. There's another also, AMMONIUM, ammonium sulfate, SULPHATE, sulfate. Calcium nitrite, CALCIUM, calcium, NITRITE, nitrite. Potassium hydroxide. Hydrogen phosphate. Zinc hydroxide. Many compounds. There are many compounds. Let's start with this few. Before starting all this, we have to remember something before this, that is, if you are told chloride, CHLORID, chloride, it means chlorine is combined. If oxide, oxygen is combined, and if nitride, means nitrogen is combined. If hydride, hydrogen is combined. If sulfide, sulfur is combined. In this way, you have to see this part. Suffix. If there is IDE, ide, then the element is combined. Just for example, iron chloride. This is a compound. It means iron is combined with chlorine. We cannot say iron chlorine. In the same way, just for example, calcium oxide. It means oxygen is combined with calcium. CaO. So calcium and oxygen are combined with each other. We cannot say calcium oxygen. That's why the ide comes. If ide comes, it means these elements are combined with the particular another element. Okay, let's start with this. If we want to write molecular formula, then we must be clear about the symbol of element and formula of the radical. Magnesium, its symbol is Mg. Chloride means chlorine is combined. And if we are writing this molecular formula, we have to exchange the valency. Valency of magnesium is 2, chlorine is 1. That's why we can transfer the valency of this element to this and this element to this. While writing molecular formula, we'll transfer the valency of element or radical with each other. Magnesium's valency is 2, but Mg1, this 1 is useless because magnesium itself is 1. That's why the molecular formula of magnesium chloride is MgCl2. In the same way, aluminium nitride. Aluminium means Al. Nitride means nitrogen is combined. Look at this. Aluminium nitride. Valency of aluminium is 3. Nitrogen is 3. Equal valency, no exchange. If there are two elements having equal valency or two radicals having equal valency, then we will not exchange their valency. That's why aluminium nitride is ALN. Ammonium sulfate. Ammonium means NH4. Sulfate means SO4. These are radicals. Ammonium has valency 1, sulfate 2. That's why we have to exchange the valency of sulfate to ammonium. But if we have to transfer valency to the radical, then that radical should be taken in bracket. And then valency of sulfate 2 is taken here. It means the whole ammonium radical is 2. That's why valency of ammonium is 1. 1 is not necessary to transfer like this. That's why ammonium sulfate NH4O2SO. Calcium NiTrite nitrite. This is not nitrate. Calcium Ca. Nitrite means NO2. Calcium valency 2. Nitrite valency 1. 1 we don't have to transfer. Valency of calcium 2 has to be transferred to this nitrite. And nitrite is a radical. That's why this whole nitrite is 2. Okay, now potassium hydroxide. Potassium symbol K, hydroxide formula OH. Potassium valency 1, hydroxide valency 1, equal valency, no exchange. In the same way, hydrogen phosphate. Hydrogen is symbol is H, phosphate is radical, its formula is PO4. Hydrogen valency 1, phosphate valency 3. That's why 3 should be transferred to hydrogen, but 1 of hydrogen we are not transferring. S3PO4, hydrogen phosphate. In the same way, zinc hydroxide. Now, zinc is Zn, hydroxide radical, its formula is OH. Zinc hydroxide, zinc valency 2, hydroxide valency 1. We don't have to transfer 1. That's why the valency of zinc is, if transferred to hydroxide, then we have to take hydroxide in bracket, ZnCl2. In this way, we can transfer valency to each other, I mean to say element or compound when combined with each other and to form, element or radical when combined with each other to form a compound, then the valency of element or radical should be transferred to each other while writing that molecular formula. But have you noticed here something? We may be confused about something. There are something which are confusing. Just for example, SULPHATE sulfate. Sulfate means SO4. This is a radical. Its valency is 2. In the same way, SULPHITE sulfite is another radical. Its valency is SO3. Its valency also 2. But SULPHIDE sulfite is sulfur is combined, its valency is 2. All of them have valency 2, but they are completely different things. Look at this one. 8 means SO4, ite means SO3, ide means sulfur is combined. This is one confusing material. We have to be very careful about this. Iron sulfate means Fe is combined with SO4. Iron sulfite means combined with SO3, but iron sulfite means iron is combined with sulfur. In the same way, NITRATE nitrate means NO3. Its valency is 1. But NITRITE nitrite, it is NO2. Its valency is also 1. But NITRIDE nitrite means nitrogen is combined and valency of nitrogen is 3. If sodium nitrate, sodium Na combined with NO3, sodium nitrite, Na, sodium is combined with NO2, but sodium nitrite means sodium is combined with nitrogen. In the same way, there is another confusion I want to make you very clear. This aluminium, ALUMINIUM, aluminium means an element Al, but ammonium, AMMONIUM, ammonium means NS4. This is a radical. And ammonia, AMMONIA, ammonia means this is a compound. Look at this. Aluminium's valency is 3. Ammonium radical's valency is 1. Ammonia is a compound. Compound doesn't have any valency because element combines with each other to form a compound, or radical combines with each other to form a compound, and that time only we have to exchange the valency of element and radical to each other. But compound doesn't have any valency. It has no combining capacity. Sometimes we'll be confused. In place of aluminium is written, but we will be writing NS4. It's wrong. That's why we have to take care of all this. This way we can write molecular formula of different compounds. Okay, this much for today.